In this video, I'd like to talk about the reflection identities of the tangent function. And in a previous video, we looked at the reflection identities for the sine and cosine function. And you can see these pictured here. And the basic process was that we started with the unit circle, and we had a ray going to a point on the unit circle where we have this angle theta measured positively in the counterclockwise direction. And the x coordinate of this point here would be the cosine of theta, and the y coordinate would be the sine of theta. And from there, we reflected this ray over the x-axis, and now we're counting this angle in the negative direction, clockwise, and we were able to relate the x and y coordinates of these points since they have the same x coordinate but opposite y coordinates. And then we took this original ray, we reflected it across the y-axis to get this point over here. And this angle would be theta, but what we're really concerned with is this angle here so that we can have the xy coordinate of that point. And this angle, if we measure all the way to the negative x-axis, that would be pi radians or 180 degrees. But if we then subtract theta from that, then this angle would be pi radians minus theta. And we got the x and y coordinate from there, and we're able to relate that to the sine and cosine by comparing their x and y values, since they have the same y values, but the x values are now opposite. And lastly, we took this ray and reflected it over the x-axis, and this angle here would be theta since we are counting in the positive direction now. And this total angle can be found if we first go pi radians to get to the negative x-axis and then add theta to that. So the entire angle is simply theta plus pi radians. And again, we compare that to cosine and sine of theta in the first quadrant by looking at their x and y values. And you can see that the x value is the opposite and the y value is the opposite. So all of these reflection identities are in the blue boxes. And it's a relatively straightforward process to rederive them for yourself. So I encourage you to try to practice this on your own to see if you can get back this same result. Now, in this video, I'd like to look at the reflection identities of the tangent function. And to study the tangent function, we just need to remember that the tangent of the angle is the sine of the angle theta divided by the cosine of the angle theta. And we can now look at these different identities but using the tangent function by just looking at the ratio of the sine to the cosine. And let's start with this relationship here where we have the tangent of the opposite of the angle, and this would just be equal to the sine of negative theta divided by the cosine of negative theta. But we know that the sine of negative theta is just equal to the opposite of the sine of theta. We essentially just use this identity and move the negative to the other side. And when you put in the opposite of theta into cosine, you just get back the cosine of theta. This is an even function, and the sine function is an odd function. And when we simplify this, we get the opposite of the tangent of theta. So the first reflection identity that we can find is that if we put in the opposite of theta, we get back the opposite of the original function. And this just confirms that the tangent function, like sine, is also an odd function. Now, moving on to our other identities here, we can also look at what happens when we add pi to theta. So we want the tangent of theta plus pi. So this would be equal to the sine of theta plus pi divided by the cosine of theta plus pi. And we know that the sine, when we add pi to our angle, we just get back the opposite of the sine function. And likewise for the cosine, we get back the opposite of the cosine function. But both of those will cancel out so that this is equal to the tangent of theta. Meaning that if we add pi, and this also works, I should mention, if we subtract pi, in both cases, we get back the original function. And the reason I say that subtracting pi also works is that this angle here can be expressed in two different ways. We can take our angle theta and add pi to that, or we can take our angle theta and subtract pi. In both cases, we go 180 degrees around the unit circle and we end up back at this point. So the other way to describe this point is that this is really theta minus pi. And that would be true for the sine and the cosine as well. So when we add or subtract pi to our angle, then in regards to the tangent function, we just get back the original function. So shifting it left or right when we look at the graph of this by pi radians would not actually change the function. And this result here, that adding or subtracting pi to the angle doesn't actually change the function, this is incredibly useful when dealing with what are called polar coordinates, where we measure a point at some point on the coordinate plane. Instead of using x and y, we use this angle theta and its distance r from the origin. And this will also be useful when dealing with complex numbers when they are written in their polar form. But you will see those in later videos. And the last one we want to look at is this relationship here where we have an angle of pi minus theta. And another way to look at this angle is that we start at negative theta and then add pi radians to that to get to this point over here. And let me make just a little bit of room so that we can plug in the values we want. And I do want to keep cosine and sine on the screen. So we can take the tangent of this angle, this pi minus theta, or negative theta plus pi. So this would be equal to the sine of pi minus theta divided by the cosine of pi minus theta. And we know that the sine of pi minus theta is just the sine of theta. And the cosine of pi minus theta would be the opposite of the cosine of theta. And this would simplify to the opposite of the tangent function, meaning that this is also equal to the tangent of negative theta, which should make sense based on these formulas we found here, that when we have some angle for theta, when we add or subtract pi, it doesn't change the function. So we are adding pi, and we would be able to shift this back to the tangent of the opposite of theta.